right? Since the last number is a 2, numbers that divide that nicely are 1 and 2, and they could be positive or negative. So if I call this polynomial again, I'm going to start with my factor theorem, remainder theorem, because if I plug in 1, it's going to be easy. Do you want to try 1 first or negative 1? 1. Usually people like 1 because it has no negatives. Now plug that all the way in. I'm going to have 3 minus 4 minus 5 plus 2. What does that equal? Not 0. So if you know it doesn't equal 0, and you don't want to actually worry about what it does equal, you can write not 0. If you want to write out what it actually equals, 3 minus 4 is negative 1, minus 5 is negative 6, plus 2 is negative 4, okay? That means there's a remainder of negative 4. That means that's not going to help us find a factor. Worst case scenario, we try them all, and the very last one is the one that finally works. Not going to be the case this time. Try negative 1. Negative 1, we're going to get negative 3 minus 4, negative 7 plus 5 plus 2 equals 0. And that means, so x, I'm going to leave it blank here for a second. Is it x plus 1 or x minus 1 as a factor? X plus 1 is a factor. Now that we've found one factor, we can use synthetic division to figure out what would be the quotient after we divide. So synthetic division goes like this. You'd write 3, negative 4, negative 5, 2. What number do I put outside? Negative 1. This number outside is always opposite of the factor. You can see where your mind is going to play tricks on you because you flip-flop once to here and then flip-flop back to there. And all that flip-flopping back and forth can sometimes be a place where you can make a simple mistake. But now we can do our synthetic division. The 3 comes down. Negative 3, negative 7, 7, 2, negative 2, 0. This is also a good way to check to make sure that you were right in saying that it was a factor to begin with. Because if all of a sudden in your synthetic division you don't get a remainder of 0, it means that you've made a mistake somewhere, either initially when you plugged it in or now when you did your synthetic division. Now we can write our division statement, which will start our factoring. P of x, which is our original factor, and we labeled it above so I can start with this. P of x is going to equal, well, x plus 1 was our divisor, and our quotient is 3x squared minus 7x plus 2. It said factor fully, so we have to decide whether or not we can factor this more. Is it possible to factor the second one even further? And since it's a quadratic, we go back to our old factoring things. We're not going to you could use the factor theorem and synthetic division again, but since you know how to factor these ones already, it makes sense just to factor it directly. If our original question had an x to the 4, then after dividing it once, you get an x cubed, and you'd have to repeat the process of using the factor theorem again and the remainder theorem again, and find another one, use synthetic division again, and then slowly break down your polynomial until you've factored it completely. Here, this has to be 3x and x if you can factor it. We're going to need a 2 and 1. Only way I can get 7 is if I put my 2 and 1 this way. They're both going to have to be negative. If I want to get negative 7, I do a quick check, and sure enough, when I multiply that out, it works. And now we've factored it completely. Questions you can do for this one? 5, 11, 9, and 10b.